Dave Orton and Brad Neels will be presenting today's webinar titled Ground Up Reengineering of the New CleanCNG Compressor. This presentation will share an inside look at the innovation and engineering behind the new CleanCNG non-lubricated compressor, critical components, cooling design, serviceability, and scalability. My name is James Carter, and I'll be your host and moderator today. So today's speaker, we have David Orton and Brad Neels. A little bit about Brad. He's an application engineer with CleanCNG Compression. He's overseen CNG projects for CleanCNG Compression for the past 6 years. During his tenure, he has been instrumental in successful deployment of CNG virtual pipeline projects in several global markets. Mr. Neels has a Bachelor of Science with honors in mechanical engineering and a minor in commerce from the University of British Columbia. David Orton, Senior Vice President, Global Business Development and Marketing for CleanCNG Compression. Mr. Orton has led substantial global market expansion for CleanCNG Compression over the past 5 years and worked closely with the research and development team to ensure a successful product improvement program such as today's ground-up reengineering of our groundbreaking CleanCNG. Without further ado, Mr. Orton.
Great, thanks, James. Before we get going as well, in the room we've got Brad, obviously James, and Christine Jameson who will be helping us out answering your questions. So if you hear her voice, you'll know who's there. Quickly on CleanCNG as a company, CleanCNG Compression is part of CleanCNG Fuels, and CleanCNG is the largest provider of natural gas for transportation in North America and a global leader in the expanding natural gas vehicle market. CleanCNG has operations in CNG, LNG vehicle fueling, construction and operations of CNG and LNG fuel stations, biomethane production, and compressor technology, as well as facility modification. So CleanCNG itself operates one of the world's largest and certainly the most modern deployed fleet of 500 plus CNG stations, 120 plus LNG stations, liquefaction plant, trucks, servicing facilities, parts warehouses, quite a remarkable organization. Of CleanCNG Compression, we've been manufacturing industrial machinery since 1912, and we've evolved to be a leader in the manufacturing of natural gas compression systems, specifically non-lubricated, serving all major markets globally. CleanCNG Compression equipment currently operates in the most demanding climates from the Middle East to north of the Arctic Circle. So we have a variety of configurations for all applications, and our product line includes compression, pressure reduction, defueling, and dispensing and filling industrial posts. So getting straight into our topic today, the new CleanCNG. This is a ground-up reengineering, as James was mentioning, as Brad will elaborate on. Our focus was several points. Number one, standardization. So we wanted to simplify the order process, speed up the delivery process, lower prices, and make it extremely simple to design this unit into a space even in advance of any details. So from 150 to 300 horsepower, it's the exact same footprint, exact same envelope, exact same positioning of inlet, outlet, and you can pre-design to the unit. Another key area was vibration, because that's foundational to a unit's maintenance and reliability. And so everything from piping layout to various other techniques were used to reduce the vibration to a point where I myself stood beside one on a gravel pad. It was unanchored, 250 horse, running full out, and balanced a Canadian $1 coin on the main part of the unit, about halfway up. So center of gravity, you know, this wasn't way down, this was up high on the unit as it ran full out. And if any of you are familiar with the Canadian $1 coin, it is much thinner than even, say, a euro. We needed to obviously focus on the cleanest possible end-user product, the natural gas itself. And so we have done advancements in ring design on our non-lubricated platform. Redundancy was another key area of focus, allowing you to literally Lego block these units together. So the platform itself, the photo you're seeing there, you can take those end panels off. The end panels of the adjacent unit are taken off. They're put proximate to each other. A bridging kit is put there, and all airflow as well as maintenance access is fully maintained because that's the way the unit's being designed. And finally and foremost, we're all aware in this industry that these units work very hard and are critical to many applications. Therefore, maintenance is a key factor. And unfortunately, many of you are aware that maintenance has not been a consideration in many compressor designs. And in this one, it was the key consideration with members of our master technician team who will travel the globe servicing our units central in the design of this machine, and you'll see many of those features displayed as Brad goes through this. So, the clean energy design. It's a single package footprint with a modular concept to build twins or triples, or for that matter, you can carry on out as many as you wish. And when you do that, you don't have to worry, gosh, is the airflow correct? Am I recirculating hot air? Am I reducing serviceability and access? Because the unit's been designed to do it. Easy serviceability with sliding in and out major components. So the unit you will see has huge doors on the back and the front that open up. It has a fully covered and protected service walkway that takes you right into the unit, fully lit and safe from the weather, that allows access to the back of the CPA and back of the heat exchanger into all electrical, so you don't have to have a tent and dry off a panel if you're in the rain. It fits into a normal 20-foot shipping container. Very rigid, vibration-free construction. We'll get into that later, describing the monocoque type frame design and what it does for reducing vibration. And again, same configuration from 100 horse to 300 horse. One design fits all. It's designed for quick manufacturing, and top or side discharge is possible. Obviously, bunker format without a manufactured enclosure is possible. With reduced welded construction with bolted elements, and all the calculations required. Here's a quick shot of the compressor itself in a twin configuration, exposed so you can see the various aspects. You'll see in this case on the back, the back I'm referring to is the part facing you with the heat discharge out the or heat intake, sorry, in the front. Frame design. Each subassembly is built in a separate cell and brought together in the end. Each subassembly can be fully rotational tested, pressure tested, electrical tested as is required, and they come together incredibly quickly onto the skid itself. We've also moved the cooler section to a vertical format instead of a horizontal top-mounted format. Couple of reasons there. Number one, bring down the center of gravity, reduce vibration, and number two, incredibly increase the ability for ease of maintenance. The cooler sections actually draw out, as you'll see in a video that we'll be releasing later on here, making them very, very accessible instead of having to bring in heavy cranes. I'd like to point out too that all of our compressors are obviously non-lube in their design, but we've also adopted a strictly air-cooled format. And I've addressed concerns before with people looking at me going, gosh, will that work in Qatar? Well, we've got units working in Qatar. We've got about 100 units working in Egypt. We've got units working in Death Valley in the U.S., all over Indonesia, Thailand, in South America. So we have never encountered an issue where our air-cooled system causes a problem. It can work extremely well in any climate, and as you can see, is very compact as opposed to the separate water-cooled systems that you might see not to mention the maintenance of a water-cooled system. The modular design, I'll just have a quick video here that you can see showing how the modules, the sub-assemblies, the monocoque sub-assemblies come together. And then I'll hand off to Brad Neels, who'll go into more technical details. Again, the new CleanCNG, its key elements: serviceability, lowest vibration and noise. We've got this down to 75 dB at 3 meters. And again, I've stood beside the unit, unanchored, and had a conversation with it running, literally right beside it. And lowest oil carryover. And with that, I will hand this over to my associate, Brad Neels.
Thanks, Dave. So I'll just go into a few more details here of the new design. So this slide that you're seeing right now shows a top view of the new CleanCNG compressor package. And as you can see, there's a walkway coming in at the top left of the package and directly into the center of the package, allowing complete access all the way around the compressor block. You can see the mannequin sort of from top view. And in addition, there's a crane rail above the mannequin's head that allows a heavy-duty 1-ton crane to be moved almost everywhere inside the compressor package, accessing the major components. In addition, the technician from inside the package has access to all of the major service items, meaning that service is easier to occur and therefore happens on a more regular basis, and that improves machine performance and increases the lifetime. So a couple of specifics on the serviceability. The first one, as I mentioned earlier, is 360-degree visual inspection of the compressor block and filter access. As you can see in the top right-hand photo, opening the front air intake louvers provides complete access to the front of the compressor block. And then walking inside the service access provides access to the rear side of the compressor block. This allows the compressor block to be serviced much easier and also allows for inspection and preventative maintenance as required. In the lower photo, you can see right under the circular cover plate, there's a tubular drain location where all of the bottle drains and vents drain into, with a main drain valve at the bottom, a quarter-inch ball valve. This allows any condensates or any liquids in the fuel stream that get trapped in the scrubber bottles to be drained into this central location. This location is accessible by opening the air intake louvers, and this vent header can be drained on a regular basis very easily. In addition, the oil level gauge is located on the right-hand side of the compressor block. It's that rectangular device with the oil level showing. This allows much easier visibility of the oil level and the ability to top up the oil as required well before it poses a maintenance issue. The third item is indicator taps that are drilled into the compressor cylinders of every unit that ships out of our factory. This provides easy instrumentation access to the compression ports if required. If there is a service issue in the field, it's very easy to take our instrumentation package, plug it in, see what's happening, and see what the issue might be, allowing for quick addressing of those issues and slower downtime.
So, Brad, just to key on that, you don't even have to turn the unit off to do that, do you?
You would have to turn the unit off, yes.
Okay.
Just to drain out the pressure that's residual in those ports.
Okay.
But quick process,
yeah.
Very quick process. The fourth item is a really big one, and that's the overhead crane. The overhead crane comes in two sections, and as we could see on the overhead view a few slides ago, one section is long and contains a 90-degree bend. The other section that we see here on this lower photo is a short, approximately 2-foot long section, and those two sections can interlock to allow the crane to roll along the entire length, or the crane itself can be located on the short 2-foot section, and that section can slide directly on top of the compressor block, allowing for removal of all of the major compressor components, cylinders, seal carriers, pistons, all of that stuff. So very, very flexible design and operation there, allowing all of the major components to be accessed. The fifth item is 360-degree access to all of the major service components. As Dave alluded to earlier, opening the air intake louvers grant access to the entire front of the compressor block, all of the bottles with their associated drain valves. On the rear side of the unit, as shown on the model in the left-hand side of the screen, access is granted to all of the heat exchanger units, relief valves, all at the main motor, all of those items, and that really helps with preventative maintenance and serviceability. The next thing is improved electrical location and lighting of the package. So there are two lights strategically located inside of the compressor package that illuminate all of the major service areas, allowing the technician to see what he's doing without needing a flashlight or a trouble light inside of the package. Eliminates the need for non-classified lighting to be brought in, which could lead to issues with the presence of gas. The electrical location, there's a electrical panel inside of the compressor package accessible from the service access way, which allows the technician to do any troubleshooting, I/O checks, etc. from within the compressor package, where he's protected from the weather. Next is the heat exchanger section removal. As you can see on the left-hand side of the screen on the model shown there, there are 5 cooler sections in this particular model that are located in a drawer-type assembly. Disconnecting the tubing from the section that is posing an issue or requires cleaning or maintenance allows that unit to become free, and that cooler section can literally be slid out of the package at waist height, for example, rather than requiring a large overhead crane to remove the cooler sections from above. All of the relief valves are easily accessible from a doorway on the back side of the package adjacent to the air outlet louvers. This really helps with ensuring that the relief valves are certified and recertified on a regular basis. They are easily accessible, can be disconnected by undoing some compression fittings, removed, tested, recertified, reinstalled very easily. No clambering inside the package between a jungle of tubing. They are all easily accessible directly inside of that access door. And then the main motor, again, through the same access door that the relief valves are accessible through, there's provisions inside of every package for a optional motor service rail that is purchased separately that can be installed, and this crane system shown attached to the relief valve. This allows that gas that's in that tank to be saved when servicing the relief valve. That was the line drained, the relief valve disconnected, recertified, reinstalled without having to drain all of that gas, which goes into the atmosphere and it's basically just blowing money into the air. And then the final item, the control gas regulator. So we use a high-pressure gas regulator to reduce the discharge gas down to 100 psi, which can be then used for actuating pneumatic valves. And this also eliminates the need for an air compressor on site to use pressurized air for this. We've, on our latest design, added a pressure transmitter on this circuit so that monitoring of that gas pressure can be done very easily. And if there is a regulator leak, for example, that would be detected so that no additional gas is vented to atmosphere. In addition, this whole setup is right at the end of the service access way, so very easy to access, very easy to monitor and service if any issues do arise. So with that, I will pass it over to Dave Orton to walk through some of the estimated savings associated with each of these improvements.
Yeah, we don't want to take too much time on this, but obviously when you do these many improvements to serviceability of a unit, you do want to sort of have some sense of quantifying what is the value over the lifetime. Needless to say, these things are wild estimates, and will vary between location, altitude, atmosphere, application, but they're purely designed to give you a sense of the scale of savings that are possible over an assumed 25-year lifespan of a compressor. You can see some of the assumptions we've made there. We also have a companion brochure that will be available detailing this and going into greater detail on each of these serviceability features. It should be available early next week. But in general, we see about 13,000 hours as a possible savings over in technician time. We see significant downtime reduction, and we see significant failure avoidance just because of the sheer serviceability and ease of service. We all know that what is easy to do, we'll do more often. And that has been the core focus of this development project. So, if it's a $500,000 savings or $100,000 or $200,000 savings, bottom line, it's a big savings due to these innovations. One of the key things that we're focused on here is lowest vibration and noise. As CNG markets evolve, and because we're involved globally, we see markets at different phases of their evolution and penetration. But as they evolve, the bigger compressors start to move into the urban areas, and the demand for noise reduction becomes extreme. At the same time, of course, urban environments are becoming much more sensitive to noise levels and regulating them more aggressively. So our focus was on get the vibration down, reduce the noise levels. And we've achieved 75 dB at 3 meters. We actually see less than that in many cases, but as you know, that depends on many factors. And you can comfortably hold a conversation like we're having outside, standing right beside a unit running full out. The vibration, this is quite a detailed diagram here. I won't pretend to interpret it. I'll let Brad talk to this one.
Sure. So this is a plot of some of the vibration levels that we've measured on the compressor that we designed. As a maximum value, in the past we've used 1.2 inches per second as the maximum allowable vibration velocity rate. And as you can see on this plot, every single point of the package that was measured was well below this limit. In fact, in most cases we're below 0.4 inches per second on the compressor block, lower on the frame, and even on the enclosure, at the points furthest away from the skid base, we're in the order of 0.6 inches per second at the worst case. This was measured on gravel, as Dave alluded to earlier, So this was not even anchored to a concrete pad, which typically tends to reduce vibration levels even further. And the vibration is low enough that a $1 Canadian coin can stand on edge, and there is a YouTube video that shows the test that was done indicating this.
Now, as all the technicians out there listening will attest to, of course, compressors can tend to shake themselves loose in many cases, and the further you can reduce the vibration logically, the better your maintenance schedule is going to be, and that was a real key focus, as well as, of course, reducing the noise levels. And speaking of reducing the noise levels, I'll let Brad speak to this diagram here.
Sure. So this diagram shows some of the test results of our new compressor package, tested out in the back lot behind the factory. In all cases, the noise levels measured even at 1 meter was lower than 80 dBA, and at 3 meters was below 75 decibels. These levels will go up just as a matter of the loss of the sound attenuation measures being removed.
One thing to note, though, again, hearkening back to the fact that this is an air-cooled machine. Often you may see measurements on water-cooled machines taken beside the machine with the water-cooled platform elsewhere. These measurements are taken with the full package, including the heat exchanger. If you take a water-cooled heat exchanger and drop it on top of a water-cooled system and then start taking measurements, your noise levels will change substantially to the work. The key thing to remember here is you are looking at a completely integrated package with all cooling and all the components required on this footprint and within this envelope by these noise measurements. One of the key focuses, again, we've been speaking about it, but I really want to come back to it, and that is our non-lubricated Wblock. We have dedicated ourselves from the beginning in '84 to a non-lubricated configuration. Our R&D continues in our ring design and in reducing the oil carryover. You know, we deliver gas with oil carryover about equivalent to what's permitted in a scuba tank right now. And again, not all non-lubricated compressors are created equal. And I have personally seen statistics from other would-be non-lubricated compressors showing oil carryover substantially higher than these levels. So our focus is don't introduce the oil at the beginning. Certainly don't inject it into a cylinder and then try to remove vaporized oil from a hot gas stream, which is many of the engineers out there will know is less than a science. And then, of course, you have to deal with the disposal of those oil-soaked filters and, of course, the storage of the oil on site. Again, here is a quick view of the shear access that you have opening the inlet louvers to the full side of the CBA. The right-hand door there is actually covering the other walkway access door that Brad was speaking to, and that walkway access goes in and in an L shape right behind the compressor, giving full access, lit and protected from the weather, to all of your control points and electrical. We won't jump into the technical specs, but I'll let Brad maybe expound on the breadth of specification. But one note that was brought to me by a customer deploying a large number of stations was, they said, do you realize that your compressor block covers the broadest spectrum of specifications of any compressor block in the industry? And I actually had not realized that. But the bottom line is the configurability of the CEC Wblock is extensive, and indeed does cover the largest spectrum of any single block in the industry, reducing training and spares and any number of other benefits. But maybe, Brad, you can talk a little bit about the general specifications.
Sure. So in general, as Dave mentioned earlier, I won't focus too much on the top lines there. That's sort of dry facts. But the unit comes, no matter which configuration is ordered, the unit will look the same from the outside. The gas line connection location is always in the same location, and there's only two different options with regards to the inlet size. It's either 2-inch or 3-inch, depending on the pressure and the flow rate of the unit. On the discharge side, there's only two different options, either a 3/4 inch or a 1-inch tube connection. Again, those are always in the same location, so construction can occur on site well before the package shows up. Our packages are offered either in a Class 1 Division 1 or Division 2 hazardous area rating. The motor control center for controlling the package is will be present. The main motor power ranges as in a standard range from 150 to 300 horsepower, with 100 and 200 horsepower versions optional. Soft starter is standard with all of these units, or a variable frequency drive could be purchased as an option. The units are designed for 50 or 60 hertz in a variety of voltage options. The gas priority panel can be either mounted on skid for the international market or off skid in a standalone enclosure for the most flexibility with regards to installation location. Standard code compliance is ANSI, ASME, NFPA, UL, CSA, with option for CE, PED, ATEX certification in Europe coming very soon. The standard elevation range is 0 to 2,000 meters. Elevation above that can be handled, but may require a change of cooling fans just due to the lower density of the cooling air.
Brad, just to jump in here, we've got a bunch of questions too that I want to grab, but there was one question here about the lower level capabilities of inlet pressure for the unit. What is the lowest inlet pressure that our block can manage?
So we can get down right to about 2 to 3 psi. Our standard units, the lowest pressure range that we currently offer as a standard unit is 5 to 10 psi, but it's a fairly simple matter to go lower than that. Depends on the flow rate and the basically the capacity required from the unit. Style compressor that can compress gas from a tube trailer for CNG applications that are off-grid, and those units can accept up to 200 bar at the inlet pressure.
Excellent. Now, I've just got a couple other questions here. Is there any energy efficiency improvement in the new compressor coming from Alexi?
Absolutely. So part of the new design was focused on reducing the pressure losses in the piping between the compressor block and the cooler. So we've gone to bent piping on inlet and often on first and second stage interstage piping. We've noticed great improvements in the pressure losses, which has reduced power consumption. In addition, we've gone to a new style of compressor valve. So internal to the compressor block itself, we've gone to a more efficient compressor valve. And in general, when we're sending out the specification sheets showing the predicted performance of our compressors, when they go to the test bay, we are often 5 to 10% higher on the flow rate compared to what we predicted, and several 2 to 5% lower on the power consumption that's been predicted. So yes, definitely some improvements made there.
Excellent. And for our international clients, speaking of power and power consumption and power costs, I know in BC we're not that worried about electricity costs, but we do have a gas engine drive unit called the unplugged CNG. and those are used in applications Africa, Indonesia, Egypt, where either power is intermittent or power cost is prohibitive. Now, another question here coming from Gary, are the 5 cooler modules all the same or custom for each stage of compression?
Sure. So we've narrowed it down to, I believe it's 8. Is it 8? It might even be lower. I don't know the exact number, but there's about, let's say, 8 cooler sections that are used throughout the entire range. And so those individual sections can be allocated in 11 different configurations. So, of course, for a 3-stage compressor, we would only use 3 cooler sections. And so we've got a number of 3-stage, a number of 4-stage, number of 5-stage cooler configurations, total of 11, and different combinations of those 8 base cooler sections.
Excellent. Coming to you again, compressor liquid drain heated for cold climate installation. Do we know anything about cold climate?
So the drain is internal to the compressor package, and in cold climates we install a space heater inside of the compressor package that's sized to maintain the internal temperature above freezing. So that will keep all your liquids, everything inside that package above freezing, allowing you to drain.
Okay. Interesting question. How much will the noise increase without the enclosure?
So that's something that we haven't tested, because in general the vast majority of our units go out with an enclosure. But these fans are rated around 85 to 90 decibels. So again, you lose that. That's at the fan itself. So the further you get away from that, the lower your noise levels. But we expect to see around 80, in that order, say 90 decibels at equivalent distance.
Yeah, the only experience I have is actually having a conversation with all of the doors open and the unit running, and I was able to have a conversation at this volume level. What are the liquid and hydrocarbon dew point temperature requirements for the incoming gas at compressor inlet?
So that's a really good question, and it does depend on the region that we're operating in. Essentially, that temperature needs to be below the minimum expected temperature of that region. So in general, in Canada, we say that's got to be minus 40 degrees. Some areas in Latin America or Africa, for example, where the temperature never gets below 10 degrees, we could accept temperatures of 0 degrees, for example, because the issue is you never want to be operating in the region or at the temperature that you could have heavy hydrocarbons dropping out of the gas stream.
Here's an interesting one. If you have 2 compressors connected together with only one running, is there a barrier between them to prevent warm air from recirculating?
Yes, there is. So we actually remove the aluminum skin off the exterior of the package, but the interior wall panel remains, and so there you still have the insulation and perforated carbon steel skins between the two packages, and that does 2 things. That prevents the warm air from recirculating, and also it reduces the noise level. You don't have the combined noise of 2 units going out through one louver.
And just to clarify, if you can picture when you open up that front access door and enter the access walkway, to your right on the wall there are these panels that have the recessed twist locks on them, so that you literally pull out the handle, twist it, and pull the panel off so that you can fully access, in this case, the motor end of the adjacent unit.
Yeah, so that would be, you're right. So there's 2 main access panels on that wall. Removing one of them gives you access to the left-hand side of the compressor block. So for removing the piston rod, for example, from that wing, it would actually come out through that access hatch and into the adjacent compressor package. And then there's a second access hatch that allows you access to the slide base of the main motor for tightening and loosening those bolts.
The bottom line, Rob and audience, is that the compressor has been fully designed to maintain, number one, the integrity of its airflow and cooling system, and number two, full accessibility and serviceability features. So when you put these together in a Lego block fashion, it's been specifically designed to allow full access in that configuration as well as by itself. So it says here, what are the consequences not having the package? I'm assuming that means not having the enclosure.
Sure. So there's a number of things. The airflow is slightly degraded because we're not funneling it as well as we like to with the enclosure. For example, the inlet louvers on the compressor package are specifically designed to direct the airflow over the compressor block, which keeps the compressor block cooler, reducing interstage temperatures and the oil temperature. Again, the noise level is a big one that increases without having the enclosure. And then the final thing is a safety consideration. The compressor package is designed in the worst case of a component blowing loose. That compressor package, the wall panels are designed to take the impact and reduce and severely mitigate the effect of that, whereas without that, we generally recommend that there's a barrier or something preventing the public from accessing this package.
Great. Rob is asking what type of heating is provided in the cold weather package.
Sure. So it's a, I can't remember the type right off the bat, but it's an electric space heater with a fan on it that essentially heats up and circulates warm air through the compressor package. It's thermostatically controlled, kicks on automatically when the temperature drops below zero, and then automatically turns off once the temperature comes back up.
So for those of you who know Canada, we've got these operating quite effectively in Winnipeg, or Winterpeg as we lovingly call it, and that gets down to -40, -50 outside. We've got it up in Barrow, Alaska, the most northerly install of any compressor in the world. We've got it working in Nizhny Novgorod in Russia. So great experience, obviously, with the cold and the hot. From Steve, how much oil does the block use, or is the block oilless too?
So the crankcase itself is lubricated because we need oil to lubricate connect the crossheads, between the crossheads and the crosshead guides. There's a thin film of oil between those two. So as those crossheads are moving up and down, moving the piston up and down, there is oil in there. The crankcase itself holds about 40 liters of oil, and then that's topped up as necessary. But again, with oil carryover rates below 5 parts per million, that might be a few hundred milliliters at most per month.
Yeah, it's very, very nominal. In fact, we've had clients who've had other non-lube and lube compressors completely disbelieve the amount of oil that would be required, or the low amount of oil, and we've had to prove it to them by referring them to other clients. So it's a very nominal amount of oil that's used. What is the estimated lifetime for this CleanCNG?
So again, that's in line with previous estimates of 25 years if maintained properly. Regular service intervals, replacing some of the components at their recommended intervals, but we definitely have units in the tens of thousands of hours out there in the field and still going strong.
I think one of our top ones is 70,000 hours, I believe, and it's not in the most ideal or best serviced area. It's definitely a third world installation. I was at the World Gas Expo in France, and one of the fellows from CNG came up, and they had purchased one of our units, one of the original units from, what was it, 25 years back, and had moved it to another location in Europe. And I mean, number one, it's still functioning perfectly after 25 years, and number two, they actually disassembled it and moved it, and it's operating again in a new location. And any of you who know old equipment, that's a little bit of a scary proposition, but it's working just fine. So that might give you a sense of it. This has been made to the oil wiper system. Is this backwards compatible with older units?
Yes, that's correct. So we've been working very closely with our ring suppliers to improve the technology to strip that oil off the rod, and the newest designs that we're currently using are backwards compatible.
And I believe I have one more here from Roberto. VFD versus line starter, which is the ballpark figure of percentage energy savings?
So we don't offer a line starter. Our standard offering is a soft starter, and so I can't speak to that direct comparison. But the benefit of a frequency drive is just on the starter, on the starting operation, it reduces the current inrush to the motor, whereas where a soft starter may get up to 4.5 times the full load amperage, a frequency starter can reduce that to about 2 times. So where we really see the savings is in areas where the utility would really charge a premium for that inrush current, and a large savings can be achieved by reducing that. So we've had a couple of recent projects where that's been the case. The utility couldn't handle that large inrush and would have charged a lot of money either to upgrade the utility, which would have been in the several hundreds of thousands of dollars, or charge them a premium every time they started up the unit. So that's generally where we see the savings is from the utility.
Okay, and I have one more here from Hank. What compound are you using in your mounts to cut down on vibration, and or is it in the balance of the shaft by weighted flywheel, and will this be easy to clean coils and or remove them?
So the main measures that were taken were the flywheel mass balancing to reduce the vibration at the source, and then the second is in the bracing of the unit and in the monocoque design of the package. So whereas previously we had a number of sub-assemblies, such as the cooler assembly, which was mounted high up in the air on a bunch of legs, that would really get going from the vibration, and that would actually amplify the vibration within the package. Now with the monocoque design, as well as lowering that cooler assembly onto its side cavity, that has reduced the amount of unsupported mass, just reducing the vibration.
We're not really using compounds
Correct.
On our mounts. We're not using buffers, if you will.
That's right.
How many discharge lines does the new compressor have?
So each compressor package will have its own discharge line. So if you would have 1, 2, 3, 4, 5 all lined up side by side, you'd actually have an individual discharge line. International packages where we offer an on-skid priority panel, you would actually have a number of outlets corresponding to the style of the priority panel that's used. So on a single line priority, one discharge line to the dispenser connection and one to the storage connection. On a 3-line, you would have 6 outlets, 3 to dispensers, 3 to storage. So in general, it's a single outlet line, but that depends on the priority panel option chosen.
Okay, well, they keep on coming in. Sebastian, when we put more than 2 compressors together, how do we put together all the electrical?
So electrically, the units are, there's no difference between having 2 units individually mounted, 10 feet apart from each other, or side by side. So each unit truly is a standalone package. They are just installed side by side on site for reduction of space, basically. Electrically, those units still operate the same, and again, even from a gas flow perspective, each unit has its own inlet and outlet connection. Mounting them side by side as a twin or triple unit doesn't change that. So.
Now, as far as control architecture goes, though, there is a bit of a difference there when you're putting multiple compressors together, is there not?
So there's a master control PLC that goes together with every single unit or every single site. So you'd have one master controller per site, and that unit, when it leaves this factory, is configured to control the number of units that have been shipped to that site, and it'll automatically alternate the starting, for example, to balance the hours between all of the units on site. And that's a PLC software update that can be done if you're adding a third unit to a site with 2 units, for example.
So I guess we're coming up on time here. Oh, Sebastian, one more. Another question. How is the increment of temperature in the discharge? How is the increment of temperature in the discharge? I'm not sure what that question means. Sebastian, if you have a moment and could fire off a clarification on that, we'll try to address that one.
So, well, I can speak a little, and something I forgot to mention about the cooling system is because of the efficiencies we've gained in the cooling, we can actually, in many cases, what we've implemented is what we call eco mode in these units. And there's a thermocouple that's mounted in the discharge line of the final gas, and if that temperature gets well below or well within the target temperature of the cooling, we can actually turn off one of the cooling fans to save energy. And so what we'll see often is there'll be one fan that'll turn on for, say, 5 minutes, and then it'll turn off for 5 minutes. And then that discharge temperature will come down to 5, 6, 7 degrees Celsius above ambient. One fan will turn off, that temperature will come up a bit to 12, 13 degrees, and then that process will repeat. So there's actually some energy savings that can be realized with this eco mode feature. So I'm not sure if that addresses the question. But in general, we are monitoring both the ambient temperature and the discharge gas temperature, so it's very clear, it's very easy to see what the difference is between those two.
Excellent. Okay, thank you everybody for such a lively exchange of questions. I'm not sure I've ever seen a webinar with that many questions coming in. This is fantastic. We will have additional resources that will be coming out, and they will be posted on our new website, which is cleanenergyfuels.com/compression. Some of those tools that are currently available is our new all-in-one brochure, which is up there showing the full line of product, compression, pressure reduction, dispensing, and filling. And then there's a specific brochure on the compressor itself. And then additional resources that will be coming out within the next 2 weeks are a quick video covering the sales points and benefits and features, and a more detailed video covering all of the service features that Brad was just talking about. Additionally, there's a companion brochure specific to the serviceability features and their value. So if you want to stay tuned for those, or drop Christine Jameson here a quick email at sales. For those, we can send them out to you, but they will be available on the website, absolutely. So in quick summary, what has been designed here by the engineering team is a complete rethink on the compressor, the skid itself in a very quick fashion, allowing us in the future to actually build them in advance. And then, of course, the monocoque design itself, the way that every single pipe run is being considered has reduced vibration to an extremely low level and reduced by that nature of the noise to a level heretofore unseen in a package of this nature. Maintenance, of course, has been improved through further reduction of oil carryover, reduction on the vibration, and every possible design and convenience considered from the standpoint of your maintenance technicians, including electric, protected, well-lit environment, full 360-degree access to every component, built-in overhead crane systems for pulling out heavy components rather than your technicians wrestling and risking injury as they pull them out doing their rebuilds. So this is a major step forward, unseen by any other manufacturer. The units themselves are now we've deployed over 50 in North America and in South America. The design for international 50 hertz, international 60 hertz, being C1D1, is being completed, and the European C1 Zone 1 being completed this time as well. So it's a very exciting time for CleanCNG compression. We're continuing on the standardization evolution in our product roadmap across our product spectrum. And we have probably 3 years of solid engineering work to accomplish here, including moving to more standardized complete systems, that being all-in-one skids, and mobile systems. And we'd be happy to talk to you about any of these. So without further ado, I just want to thank you very, very much for participating and hanging in there. Remind you about the engineering education credits that are available here, and also remind you to stay tuned to our website for these additional resources that will be coming your way. Thank you very, very much on behalf of Brad and I saw one last comment there from obviously an engineer in the crowd that says, "Beautiful design, well done engineering team."